All right, welcome back. Let's take a look at LeetCode 70, climbing stairs. So this is a pretty easy problem according to LeetCode, although I think it'd be a little bit challenging if you don't know the trick. This is also a classic example of a dynamic programming problem, and we'll see why in a second. But basically, you're taking a staircase, or you're given a staircase that takes n steps to reach the top, assuming you take one step at a time. But the trick is here is that at every step, on your way to the top of the staircase, you get to make a decision. Do I want to take one step or do I want to take two steps, right? And basically, it's asking, well, in how many distinct ways can we actually climb to the top? And basically, if you don't know off the top of your head that this is a dynamic programming problem, a thing that kind of gives it away is this thing right here. How many distinct ways is generally one of the things that is asked of it's basically a hint that you should probably try to use dynamic programming. Another thing is like what's the maximum or what's the longest. Generally, those are like dynamic programming problems. But let's take a look at this problem. I'm going to show you two methods. I'm going to show you the classic O of n space complexity method just because I want to show you guys the thought process and how this whole process works. And then from there, we can optimize this solution to the O of one space method because we're going to connect it to a certain mathematical concept. And like, if I'm being honest, I wouldn't really even know this problem that well if I didn't see it already in a math class that I took. So let's get to it. Let's open up Paint. So let's see. So let's look at this. So let's look at a couple of base cases. 'Cause that's something you always want to do when you're talking about dynamic programming. So what if we have just a step of size 1? And let's say we're here. How many ways can I climb this stair? Well, I can't take a double step because I'll just fall off, right? I won't reach the top. So I can only really take one single step to get to the top. And this is going to be the case of n equals 1. Cool. All right. What about if, let's say we have our other case? What if we have 2, right? We can we want to go up to here. So our goal is to get up here, but we're going to start from here. Well, in how many ways can I get to the top? Well, I can do the classic, right? We can just go up here once and then go up here once and we're at the top. Or as we know, we can just instantly do this, take a big old double step and we're going to be at the top, right? Awesome. So this is going to be the case for n equals 2. These are our two like base cases, right? So we know that there's one way to climb a stair of height 1 and there are two ways to climb a stair of height 2, right? Because if we were like here, for example, we would try to take a step of 2, like we would just fall off. So there's really, we can see that there are only two ways. Let's visualize a bigger example, not by a lot, just by one. Let's say we're dealing with n of 3, right? So what if it's of this size and we want to get up here? This time, instead of looking from the bottom, let's think about this problem from the top. And I think this is going to be the trick. So how? So we know we can take one step or two steps, right? So that means the only paths leading to the top here, if taken from here, I can only go one. I can do this, right? If I'm going from here though, I can go like this, take a two-stepper, right? I can take a two-stepper from here, or I can just do a 1 and a 1, right? So let's think about this then. Given those restrictions, isn't it true like that we can split this up into subproblems? Like if these are the paths I can take to get up here, wouldn't the total amount of ways to get up to here really be contingent on how many ways there are to get to here and how many ways there are to get to here, right? It would be the summation of that, right? Because once we're here, we could just simply take one big step or two tiny steps. And then, or once we're here at the green, we can take just one tiny step. So really, to get to the top of this staircase, which is going to be n of 3, right? We're going to be, it's based on the idea of how many ways are there to get to the step just before it, right? To take that one step, or how many ways are there to get to the step just before? right? To the n minus 2 step. So that's all that this really is, right? Those are the subproblems. So in this case, it would be, okay, well, if we like type something out, we can say like f of n is going to equal to f of n minus 1, right? All the ways to get to this green step. In fact, I'll highlight it green for you, right? Plus, let's keep this black, plus all the ways to get to this blue circled step, f of n minus 2. That's what it is. And what does this look like? What does this function look like if you've taken some math class that's dealt with this, right? This is the function for the Fibonacci number, right? This is the function for the nth Fibonacci number. And this is really what this problem is. It's a dynamic programming problem that's very closely related to the Fibonacci numbers. So let's write this in code. But first, let's write that O of n solution I was talking about so we can really see what we're doing. So let's first make a base case. So we'll say if n equals 1, let's instantly return 1, right? There's only one way to get it up to a staircase of size 1. Otherwise, let's have our vector, right? Let's store this data. Let's delete this. Let's not think about this function for now. Let's delete it, right? Because we can think of it as an array, right? So let's say the 0 index is going to be just 0, because if you have no stairs, there's really no way for you to climb it. We know the 1 index has one way to climb it. The second index, right? So a staircase of size 2, we know that there are 2 ways to climb it. These are our base cases. And then we saw for the staircase of 3, it's basically all the way to get to this staircase. So it's all the ways to get to a staircase of size 2, which is just 2, plus all the ways to get to a staircase of size 1, which is 1, which is going to be 3. So there should be 3 ways. Cool, right? Okay, well, let's try to put this in a code. So we're going to store this. So I'm just going to use a vector of integers. We'll say dp. I'm going to say it's going to be of size n plus 1, because at the end we want to reach the nth staircase. And I'm going to say it's going to be we're going to fill in all the default values to be 0. So let's do this. So let's say, so we know our base cases. So dp of 1 is just going to be 1. There's one way to climb a staircase of size 1. dp of 2, as we know, is going to be 2. There are 2 ways to climb that staircase. And then basically, we're going to start for int I equals 3. We're going to start at 3, right? Because we already computed, we know the values of 1 and 2. And we're going to build on top of this. So we're going to say, okay, well, while I is less than or equal, this time we want to say it's equal to n, right? Because we want to compute that nth stair. We're going to just increase I. And we're going to say dp of I is basically equal to all the ways to climb the stair just before, so I minus 1, plus all the ways to climb the stair that's 2 before, right? Taking that 2 step. So I minus 2. So another way to think of this is to think of, okay, the ways to get to the ith stair is all the ways to take a single step from where I am, and all the ways to take a double step, pretty much, right? And from here on out, this is as simple as simply returning dp of n, right? So let's see if this runs. Awesome, let's do some test cases. Oh, too soon, got too excited. It runs, cool, let's submit this. Cool, it runs. It's supposed to be pretty fast. But we can make this a little faster, and you might be asked this in an interview. How do we make this faster? Well, or not faster. How do we make this use less space? Well, we can actually not use this array, right? Because we saw that recursive function in Paint that we talked about, where we talked about like, you know, f of n is equal to f of n minus 1 plus f of n minus 2, right? This is the Fibonacci sequence, right? This is the function for the nth Fibonacci number. And you see that n is only ever dependent on the last number and the number, or sorry, it's only ever dependent on the number just before and the number just before that one. right? So we only ever have to store the 2 previous values, right? So how do we do that? So we will keep this base case, but we won't need this vector anymore, right? And we'll say like int first is going to equal to 1. So int first is going to equal to 1. Int second is going to equal to 2. So climbing a stair of size 1 is going to be 1. Climbing a staircase of size 2 is going to be 2 ways. And then we're going to keep this same for loop, but we're not going to update this right here. So we're going to say int, we'll call it third, right? So int third is going to be equal to the amount of ways to climb that first staircase plus the amount of ways to climb the second staircase, right? So this is just the Fibonacci sequence. So it's going to be this, but then we want to update our values, right? So we kind of want to shift them. So for instance, in this case, let's delete this. Let me switch back to my pen, right? If we're computing 3, let's say we have first f is going to equal to 1, second is going to equal to 2, and we want to compute third. So we say, okay, well, third is going to equal to 1 plus 2 equals 3, right? But now I want to make the first value be 2, right? And then I want to make the second value be 3. Right? It's because like we're kind of shifting. We're only ever looking at 2 values at a time in the array. It's kind of like it's like a sliding window type deal, right? So what I'm going to do is I'm going to say, okay, cool. Well, first is going to equal to second, and second is going to equal to third. Awesome. And then at the end of the day, all we're going to do is return second. Let's run the code. Submit. Awesome, it works. And there you go. We're using a lot less memory now, relatively. And that's all there is to it. It's a pretty simple problem once you know the trick. I feel like if you don't know the trick, you kind of have to learn it. But once you've seen this trick, it's kind of hard to forget. And yeah, I hope this video helped.